Welcome back to channel, guys. In the previous class we saw the floor loads and how to apply the floor loads. In the floor loads we saw there is a self weight of the slab, then your floor finish load, and then there is your live load. Okay, so we saw in the previous class that is floor loads. In today's session we will see the wall loads. Okay, so I will explain you that how to calculate the wall loads. Here is Here you see the floor to floor height is my 3 meter, okay? And here you see the columns and here you see the beam. This is my beam. That is up to that is 15 inches down. That's mean there's 375 mm. Okay. So here is the height is 3 meter floor to the floor height, and here is my depth of the beam. So wall will be construct from this floor to this beam. Okay, up to the bottom of the beam. So if I want to know the height of the wall, I want to calculate the height of the wall, then I need to minus that depth of the beam from my floor to floor height. Okay, so if I minus 0.375 from 3 meter, then I will get the value of 2.63. Here you see the wall height from this floor. So this is how you can calculate the height of the wall. Okay, and then you can do the calculation. 0.230, this wall thickness is 0.230, that's mean 230 mm wall thickness. And what is 20? 20 is nothing but the unit weight of your brick. Uh, and from where you get this value of the 20? For that you need to read the IS code, IS 875 part 1 for the dead load. If I come to the IS 875 part 1, it is on the page number 6. Here you see the bricks. Okay, for common burnt clay bricks, here is the value in the kilonewton and here is the value in the kg per meter. So for the engineering bricks, 21.20. For heavy duty brakes, you need to read the IS for this, but we do not require that. Press brakes, here you can see the values, and sandline brakes, and here you see the sandline brakes 20.40. So we take the average value that will be 20. So from here we get this value of the brakes. Okay, from the IS 7.8. So we take the value for the brakes unit weight of the brake that will be 20. Okay, so here you see the thickness of my wall 230 mm and 20 is the unit weight of the brick and height of the brick into height of the brick, that is 2.62. Here you see. Okay, so by calculating that I will get the 12 kilonewton per meter load. This is not this total complete wall load. Okay, this wall is constructed here. This is not the total load of this wall. This is kilonewton per मीटर, यानी हर एक मीटर जो आपका बीम रहेगा उस पे अगर आप कंस्ट्रक्ट करोगे ये मीटर का हाइट और ये थिकनेस का वॉल 230 mm थिकनेस का वॉल प्लस दिस साइड। यहाँ पे देखो मैंने बॉक्स बना के रखा है ये जो बॉक्स है और यहाँ पे मैंने 1 मीटर का लेंथ निकाल के रखा है, मतलब मार्क करके रखा है। यहाँ पे देखो ये जो बीम का अपना जो लेंथ है 4.1 मीटर। So if I mark for 1 meter each and every 1 meter, you will get the value of 12 kilonewton per meter. यानी ये जो 12 kilonewton per meter का जो लोड है वो आपके हर एक मीटर पे अप्लाई हो रहा है। ओके, 230 mm की वॉल अगर मैं 2.63 हाइट के लिए कंस्ट्रक्ट करता हूँ तो हर मीटर पे मेरा ये 12 किलो न्यूटन का लोड अप्लाई होगा। वैसे इस एक मीटर के लिए भी 12 किलो न्यूटन का लोड, फिर एक मीटर के लिए भी 12 किलो न्यूटन का लोड, वैसे ही हर एक मीटर के लिए ये 12 किलो न्यूटन का लोड अप्लाई हो रहा है। This is my UDL, uniform distributed load. Okay, so I hope you understand how to calculate the wall loads. We need to minimize the depth of the beam from the floor to floor height. Okay, then what kind of thickness you have for that wall, that is just needs to put here, and 20 is for your unit weight of brick, and you need to calculate the height of the wall and you will get the value, and it's applied on the kilonewton per meter. Okay, on each 1 meter you will get this load is applied. Okay, I hope you understand this how to calculate the wall. let's come to the ETABS. Okay, I come to the ETABS here, and here you see what kind of this beam is. I just click on this beam, and I will right click. So here is the assignments. Okay, what property we assign here? 230 into 450. Okay, and what floor to floor height is 3 meter. If I right click and add modify layers, and I go to modify show story data, here you see the my typical height is 3 meter. So floor to floor height is 3 meter. Okay, so my depth of the beam is 450. So I can calculate. Okay, here you see the beam 230 by 450. So depth of my beam is 450. So if I minus 0.45 0.450 from 3 meter, so I will get the height of the wall. I will just show you. One calculator. Here you see my upload to height is 3 meter into 3 meter minus 0.450. That is my depth of the beam. So I will get the value of 2.55. Okay. So what I will do 2.55 into the unit weight of 3, that is my 20, into the thickness of the wall. So my wall is 230 mm, so 0.230. I will get the value of 11.73. So approx I can take the 12 kilonewton load. So on this beams 12 kilonewton load is coming on kilonewton per meter. So on each meter my load will be applied 12 kilonewton. Okay, and here you see my here the beam size is different. If I click on this beam and here you see the geometry 230 by 375. So depth of my beam is 375 here. So if I want to calculate the wall load for coming on this beam, so again I will open the calculator. So I will minus that 3 minus 1,275. That is my depth of beam. So I will get the value of 2.62. Okay. So 2.62 into 20, that is unit weight of the brick into thickness of the wall. So here you see I will get the value of 12. So approx I will take the wall loads, that will be my 12 kilonewton on each beam. Okay. So if you have the internal walls, like here you see this, let's consider this. These are my the external beams, and external walls have the thickness of 230 mm. Okay. So 12 kilonewton load is coming on my external walls. And if you consider this is my internal beams and I am constructing internal walls on such beams. So and the thickness of the wall is let's consider 6 inches. Okay, internal wall thickness is 6 inches. So we need to calculate the wall load for the internal walls. So it is easy. Just open calculator. Okay, so floor to floor height is 3 meter, and let's consider the depth of the beam is 450 as we given. So 3 minus 0.450. We will get the value of 2.55. Okay, so I will do 2.55 into 20 unit weight of brick into the thickness of the wall, that is 6 inches. That's not 0.150 into 0.150. So I will get the value of 7.6. So my internal walls, that is 150 mm. So what kind of load is coming on that wall? 7.65 kilonewton per meter. Okay. So now I hope you understand how to calculate the wall loads. So how can you assign the wall loads on this our structure? Okay. So there is a concept of similar story. Okay, you can go on each and every floor and you can assign the lowest for each floor. But this is very time taking. Okay, you have four floors here, here only, so you can go and each floor and you can assemble. But when you have a very big structure, multi-floor structure, so in that case, if you are going to each floor and assigning the load, it is very time-taking concept. So in that case, it gives us a very good option that is about the similar story. Okay, so if I right click here and go to add modify grids, from here you can also in the edit tab, edit stories and grid systems, and here you have story data. So from here you can edit that, go to modify show story data. Okay, here you see the terrace. This is my terrace level, and here only the parallel wall will come of the 1 meter. So the definitely parallel wall load will be less. So I will not make it similar story. Here you see the master story option. I will select here no. It is not my master story. And what I will do, I will make second floor to the my master story. Here I will select the yes. ओके तो सेकंड फ्लोर को मैंने कर दिया मास्टर स्टोरी बना दिया और बाकी फ्लोर्स को मैं क्या करूँगा इन पे मेरा सेम ही लोड आएगा बिकॉज हियर माय 3 मीटर वॉल्स ओके मैं क्या करूँगा इनको सिमिलर टू सेकंड कर दूंगा सेकंड फ्लोर सेकंड लेंथ पे भी मेरा वॉल आ रहा है सेम ही 3 मीटर का तो मैं इनको क्या कर दूंगा सिमिलर टू सेकंड फ्लोर इज माई मास्टर स्टोरी ओके तो ये होता है सिमिलर स्टोरी का कॉन्सेप्ट जस्ट रिफ्रेश एंड क्लिक ऑन ओके click on OK. So what I will do here, I will make here all stories. Okay. So from here, I selected the all stories. Sorry, I will select the similar stories. Okay, I will select the similar story here. So what will happen? I am on the ground floor now, and I will select the slabs. So here you see the slabs are selected up to the this floor. Okay, but this is not our part. Now I want to put the wall beam loads. That means plane loads. That means we calculate the wall loads and wall loads will come on our frames and beams are called frames by the tabs. So if I select this beam, so here you see these four beams are selected in the 3D. That is my ground floor, sorry, plinth level, ground floor, and first and second floor. Okay, so this is how easily I can apply loads on all the four floors, which I make the similar stories. Okay, so I just select the external beams like this. So I selected the external beams and what kind of load is coming on the external beam? That is 12 kilonewton. We just calculated for 230 mm wall. So I go to assign. Here is the frame load option and go to distributed and from select here the wall load. But we did not assign wall loads here. So we need to assign the wall load first. Just load it. Go to define. Go to load patterns and from here you can define the wall loads. Okay. I just assign the wall loads and I will put in the super dead and okay. Sorry, add new load. Click on the add new load and here you see the wall load is added here. Just click on OK. And we just selected these external beams and now we will go to assign frame loads and go to distributed. Then select your wall loads and the load is coming on the external walls, external beam that is 12 kilonewton per meter. Just click apply and click OK. Okay. Now I will select the internal beams. Select the internal beams. So here you see the similar stories options are already selected and all the beams selected. Okay. So here you see all the beams are selected, internal beams are selected of the three similar stories. Okay. Now I will assign the internal wall load. Go to assign, frame load, distributed, select the wall load, and for the internal wall load, my load is coming that is 7.6. I'll just apply and OK. Okay, here you see the internal and external walls, load of the walls are applied on the beams. Now we will see for the parapet wall, for the terrace roof. So I'm on the ground floor right now. I will go to the terrace floor. Here you see I'm on the terrace floor right now. And I will just click on the form step. So I can see the options of the similar stories and all. So if you are click on the similar stories and select any slab of terrace floor, it will select only terrace floor slab because it is not included in my similar story. Okay. Now we will calculate the load for the parapet wall. So I will just open the calculator. Here you see the parapet wall thickness is my 230 mm. Okay. So what I will do, I will just do 0.230 and the unit weight of the brick into 20 into height of the wall. So what kind of height of parapet wall height you are given on the side? So let's consider I just do the 1.5 meter height. Okay, and just click OK. So I will get the value of 6.9. So 6.9 kilonewton load will become on my parapet walls. Okay, so what I will do, I will select the external beams. Okay, so this is how I just selected the external beams, and I will go to assign, and here you see the 3D 1D the external beams of the parapet here and of the terrace floor is selected. So then I will go to assign, frame load, distributed, wall load is selected, and I will do here 6.9 and just apply OK. So this is how you see we applied our wall loads, that is our frame loads on our structure. So then there is a part of the load combination. Here is go in the define tab. Here you have the option of the load combination. If you click on it, here we need to add the load combination. And why we add the load combinations, I will show you. IS 456 2000. Here you see I am opening my IS 456 2000 code for the concrete. And if you come on the page number 68, here you see the table number 18, values of partial safety factor for the loads. And this is the limit state method actually, and there is a two methods in that, that is limit state of collapse and limit state of serviceability. Okay, so for the dead load plus live load, dead load plus wind load, and dead load plus live load wind load, these are the lot of the combinations will be created here. So we need to add the load combinations according to this table, page number 68 of the IS4 passage 2000. Okay, so I will show you. Here I come on the chat GPT and load combination as per IS4. Okay, so as per IS 189 875 part 5 is for the spatial load and load combinations. Okay, but if we check the IS4 passage 2000 for RC structures and IS 1893 2016 for the seismic load, and here you see limit state method as per IS4 passage and IS 1893. So a lot of combinations will be created here. 1.5 into dead load plus live load power and factor of safety will be 1.5 and 1.5 into dead load plus wind load factor of safety that will be 1.5. So you can see a lot of combinations will be generated. This is for the limit state of collapse, and here you see the load combination for limit state of the serviceability. So now, here you see dead load plus live load and partial safety of the factor that will be 1, and dead load plus wind load and dead load plus earthquake load. So this here you see the four cases will be created. Deadload plus wind load in the positive direction, negative direction, positive y direction and negative y direction. So eight cases will be for it, eight cases for it, eight, and it will be one case, that will be nine cases will be generated for the limit state of the serviceability. And For the limit state of collapse, there will be 12 combinations for the wind load, 12 combinations for the earthquake load. Okay, so that will be 24, and this is the 1.5 into delta plus live. So this will be 25 combinations for the limit state of collapse and 9 combinations for the limit state of serviceability. Okay, so that's up to 34 combinations will be created. This is seismic load combinations. Okay, so 34 combinations, but in the ETABS we generally use 25 combinations. That is mainly for the limit state of the serviceability. Okay, we will see in these all the combinations in the upcoming videos when we do the wind load and earthquake load analysis. Okay, I will come to ETABS again. But when we do just dead load plus live load, then we just need to put two combinations. That is, you can create. I will go to define load combinations, and here you see add no combination, and I will add that combination. Okay, dead load, dead load plus live. Factor of safety will be one because it is for the limited state of the serviceability. I just shown you here. You see the limit state of serviceability method and the partial of safety of the factor is one. Okay, so that's why I'm using this dead load one. I will select live load one, load gain plus link cluster one, and I will select my wall load. That's only one, and I'll just delete this. Okay, so all my loads are given and safety of the factor will be one. Just click OK. And one more combination, that is your limit state of collapse. I just shown you here. Here you see the factor of safety is 1.5, sorry. Here you see for the limit state of collapse, factor of safety is 1.5. So I will add a combo, or I will just copy of this combo. I will copy of combo. I will make a name here 1.5 into dead plus live. Okay, and I will change the factor 1.5, 1.5, 1.5. Okay, so this is a combination for limit state of collapse. And just click OK. So these are mainly two combinations will be generated when we are giving dead load plus live load, and it will add more combinations when we assign the wind load and earthquake load. That will we will see in upcoming videos. And here is the option of the tab add default design combination. If you click on it, you see two combinations will be generated. Here you see add default concrete frame design, convert to user combination and click OK. Here you see the two combinations will be generated. These are the same combination we created here. Okay. If you add wind load and earthquake load and you click add default design combination, then a lot of the combinations will be generated, like 25 to 30 combinations. We will see in the next lectures. So if you click on UD on S1 and modify show combo, here you see 1.5 factor of safety. We are just given here 1.5 into dead load plus live. Okay. So these are the two combinations will be generated same. I will just cancel and I will delete this because we've already created these combinations. Okay, these are the two combinations for the dead load plus live. I will just click OK and go to analyze and check model. If there is something error in the our model, it will show you. I will just put pi in, select all and click OK. Now here is at the left side the model checking. Just wait a minute. So I hope you guys understand the all concepts of the dead load, live load, load beneficiary and cluster load, and the wall load as well. And we will see in the upcoming videos that is the volume load and actual load. Here is the model has been checked and no warning message was generated. That's means our model there is no error. We properly created the model. Then you can save the model, go to file and save. So, okay. So I just save the model and I will end this video guys, and stay tuned for the next session. We will see in the next videos and a lot of more things to come in.